Hello, buddy. Welcome back to HBM. Last episode, we were working on whatever we were working on. Today, we're gonna work on the condenser. The condenser is this. So basically, this machine here is a machine that you can take, power it with some electricity, and it will do condensing super efficiently, like 10 times what the large cooling tower can do. And to make this thing, it costs welded technetium, which is it's actually the most annoyingly painful thing to make. Now, if you want to weld technetium, I'm not going to do it right now, but it takes about 1.1 something million HE, I think. Which is ridiculous. That's per second is it by, no, that's per second. 1.1 million per second and like 22 million per take. It's ridiculous, but that's why you're going to need a bunch of these tantalum ones. Actually, to weld it, you need like 1, 2, 3, 4. Yeah, you see what I got here? You need these guys, but then you also need an equal number of 12 of these guys. Okay. And even then, you're only able to do one weld, which is ridiculous. And I think with our current setup, we can probably do 1.5 welds, which is not enough. But the good thing is, I've already got all the welding done. So we just have to do the steel and go from there. So I'm starting up with the steel plates. I've already got them cooking up. Now, I got these copper plates that I need to make copper plates, dude. So I need 16 copper plates. Now, I got copper ingots all the way out here. So we need 16 copper plates, which is quite a bit. 1, 2, 3, 4, 5, 6. 16 is not that much. It'd be, well, last time we needed like 100 something copper plates. We had like 4 stacks of them. Dash motors now, which is gonna be the next hard part. We already have one motor over there, I think. So all we gotta do is grab like 5. Just a stack of iron. A stack of iron should do the trick. Where the heck is the iron? Shouldn't be too hard. This should be pretty easy. We also need the copper for making wires for the actual ring coils. So we need some of them. And let's go ahead and make these ring coils, right? So these are going to be made with this. We already know how to make these. These are really easy. Where do we have the other motor at, though? That's my question. Where is the other motor hiding? Up here. Boom. Perfect. And if I do this, 1, 2, 3. Boom. And then we gotta make this. I need to make 1, 2. Go ahead and do this one. Boom. Okay. Now we have to make gold coils. Oh, okay. They shouldn't be too difficult, though. I completely forgot about the fact that these are going to have to be dash motors, but this is one of the few machines that actually requires dash motors, which is 6 of those. If you know what you're doing, it's 6 of them. We need some gold. There's none in there. Gold's in here. I guess 6 gold, too? 6 gold? Really? Is it just 6 of everything? And does it need to be bakelite powder or bakelite bars? It needs to be bakelite bars, and it needs to be 6 of them as well. Or it doesn't even matter because I've got stacks of these. I have stacks of these. 24 steel pipes is going to be a bit of a problem, but we're not there yet. We still got to make the actual coils for the things. And once we make these coils, it should be pretty easy. All I got to do is that. Right. And then I got to take these over to here. And I think it's about time that we weld these steel plates up. I made 8 of these, and I need 8 of those. Well, then I need 8 more of them, but we should be perfectly fine for this. So we need to split 32 into 2 groups of 16, split the group of 16 into 8, and then take the group of 8 and shove it through. Okay, so now it's going to be making the welded steel over here. And this should be really easy. Welding regular steel is easy. Welding technetium steel takes 8 years, and it costs a billion, like million HE or whatever. It's ridiculous. It costs like so much energy, but it's to be expected, I guess. So that's gonna make 4 of those, by the way. Copper plates, obviously. And then we're on to the last few things, which are actually not that bad. You see, you'd think it'd be bad or difficult or something because, well, I have a tendency to just dump all the useless stuff, but it's not that bad. You see, I have saved some of this. We have 4 engine lubricant barrels. So, we can just shove this into here. So that is the engine lubricant done. The only other thing we need to do is those 24 steel pipes and welding these steel plates. I don't know why it's at 5 of these. Oh, it's because it hasn't finished welding all of them. Or casting all of them, I should say. Okay. It's 24 of these. It's going to be kind of difficult. 24 times 3 is... Whoa. That is 72. 1, 2, 3. 1, 2, 3. 1, 2, 3. Dude. That's going to be 3 right there. 12. 24. Let's just go to 24. That will give us 8. And it's just going to be 3 groups of 24. 3 batches of crafting. It should get us there. So that's 1. 24 more, please. I guess 48 more. It's actually as much... Yeah, it is definitely 3 groups of 24. Is this going to get us to 24? It's going to get us to 22. We're going to be 2 short. Okay, we just need 2 more. And then we can turn those into plates as well. And then to pipes. 24 pipes. Perfect. And everything's done. So I can just... Oh, one last thing. I gotta make the plates, though. Gotta make the welded plates. And I have basically the rest of the stuff we need for the RBMK done, which is why we're making this in the first place. I forgot to mention that. So basically the entire thing for the rest of the RBMK is ready to go. It's just we gotta put this thing together. And I'm already running Australian fuels. High enriched Australian and stuff are already being used. Alright, how long does this thing take to assemble? 30 seconds. That's not that bad. I remember rockets taking like a minute. How long does the actual thing take? Soyuz. I haven't made Soyuz before. And I'm sure it takes a few minutes as well. Honestly, these things that take minutes to make are actually pretty nice. Like, if it takes a long time to make, amazing. Is this done yet? This is... Yeah, okay, here we go. Now, this machine was made back in March, or added in March, or something. Pretty cool machine, right? Looks like a giant... Looks like one of them tanks from over there. Actually, it's probably the same dimensions as one of those tanks, if I check. I'm pretty sure it is. So if I just place it over here... Yeah, it's... Oh, it's actually... Wait, what? No, it's a block longer on each side. It's weird. Okay, well, that's... So it's like this, but it's got, like, extra round end caps. Very interesting. Does not have a ladder, but it does have a fan. Which is actually gonna be really cool when you see this thing running. So let's go ahead and put it all together. So you can see here, it's got the actual condensing component up there. So to actually make this thing condense properly, what we're gonna need... does it have any on the bottom? I don't think it does. So we're gonna actually need to lower this into the ground when we do this. So that way we can be as effective as possible. So just dig this all out. And hopefully this connects. Otherwise it's gonna be a problem. It looks like, yes, it is connecting. So that means now that this thing... Oh, this needs 10 million HE? Well, I think it depends on how much it's actually running. So, yeah, this is probably a perfect application for those, you know, gold-powered batteries or whatever. 10 million HE is a lot of HE, dude. A lot. Wait, well, that actually will depend on how fast... This is actually what you will need for, like, a fusion reactor. Is this thing. Bruh, you'll need this for the fusion reactor, definitely. I mean, you can do it with regular cooling towers, right? But no. No. Why not just use one of these? This takes... Can use... Oh, it's already got 10 million HE. Well, that's... How the heck does it get 10 million HE from here? What? This makes no sense. Oh, the other RBMK supplied it with the 10 million HE you needed. And this guy has 100 million HE. So I guess, I mean, it's like a tenth of what what this guy is making. By the way, this guy is actually processing like 100,000 steam right now. And if I raise up those, it'll produce like 100-something thousand. So I can actually make loads of steam in this thing. Alrighty, so this thing is basically all ready to run. It just needs to be hooked into the pipes. So that's gonna make the thing do its stuff. Let's just connect these in here. These are gonna be for the water pipeline. And then I'll have this come out this way at a angle here. So it just goes out like this, and then up. So like boom, 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 up here. Then we'll set that to water. And that is basically done. Except there's a little bit more to this. No, there isn't. So that's steam, that's water. We gotta just add in the water now, which is the hard part. It's gonna take a few minutes. You see, it's not going to be particularly hard. It's just going to be particularly annoying. It's going to be ridiculously annoying, in fact. It's going to require us to use, to make a new barrel. And probably an infinite water barrel. Actually, we could probably move one over for, like, the time being, which is not being used currently. And then just, you know, run it off that for a few seconds to get the thing full. That should be everything it's going to need. Remember, this one runs at 400,000 steam, which is ridiculous. The energy production from this should be enough to weld more titanium plates in the future. Like, this is going to be amazing. And also, if this thing can keep up with all the steam this thing produces, which it will be able to, this thing is able to keep up with any amount of steam, then basically we have energy, which is safe. Well, relatively safe, as long as I make sure it does not explode. It should not explode. It should run on the first try, and it should, if we raise it all the way up, it will reach 400,000 steam and be at risk of exploding. But the thing is that the reason it was at risk of exploding is because it couldn't keep up with the actual disposal of all of that steam. Alright, so here we got a water barrel. This is gonna go into here. And is going to put the water into the machine. We're going to have a bit of extra for this, so that way if something goes completely horribly wrong, this thing is ready to go. It's going to take a minute, isn't it? Yeah, it's kind of annoying. Alright, everything should be ready for us to run this machine. I really hope this works, because we already tested this in the creative mode world. If you haven't seen that episode, we went into a test world. And so we tested to see if this would work, and we designed this, which should theoretically function. But it's a little scary that it might not function. I have these fresh ones here, which we'll test with, rather than these ones which I've already used over here. When I was experimenting with the fuel on this guy, you see, I ended up just going with high enriched Australium on those. It generates a lot of steam if you get these guys hot enough. They're up to like 23,000 right there. You can get them very hot, because compared to other fuels, the melting point on this is like 5 to 7,000. 7,000 for the low enriched stuff, so actually pretty nice. Now you can see here, it's actually just depleting, and temperature probably raising. How much steam does this guy have? He's at maximum steam. So the reason it's actually raising is because the neutron reflectors are sending neutrons back in. Now, because of the xenon poisoning, that is what causes these to not work. You gotta keep that in mind, is that you gotta keep these guys having high neutron flux. So now we have all three in. Let's raise up these 50%. We probably gotta raise them to 100 to get it started, to kill off all that xenon in there. Because the xenon poisoning is what's killing it right now. It's, raise it up again, dude. Up to 75%. 75% is probably not going to be enough. Or is it? Okay. 17%. Raise it up again. 100%. I don't know why this is not raising up. Because previously we had this thing going like ridiculous. Oh my gosh. You know what? I think the problem is that I just am not using the ones that I've already used, kind of. Let's go ahead and take those out. This one's already at 400 degrees, so let's just shove in this one, the 400 degrees Celsius one, and see if that one will start it. Yeah, as you can see, it's going back down. It's cooling down. Okay. Well, this is interesting, because this is not working the ways it did in the creative world. Very intriguing. And also really confusing, because this should be running. Well, this one did go up. I think... Well, actually, no. Did this one go up? No. The actual neutron absorption in these guys is too much, I think. Or the xenon, I should say. Maybe we needed to ignite it. Like, to actually just start it with radium. That might actually kickstart and destroy a lot of the xenon. That could work. Not sure how. Is this gonna work? It just destroyed all the xenon. It's down to 0.034 or something. And once these get high enough temperature and high enough flux, then these things will be perfect to start, to maintain the reaction when I switch over to this guy, who's at 22%. Let's go ahead and switch out this guy for this guy, because this guy's at a... this guy's at a higher temperature. Let's get them all up to the same temperature and then switch them out. It's weird that it's not working like it should.